So let's begin with the kinematics graphs. And first of all, uh, we begin uh, with the concept of speed. That speed is the distance traveled per unit time. So the formula becomes speed is v, distance is d upon t, or v is equals to s upon t. Right now, if I draw the graph of for the speed, so I have to draw a distance time graph, right? Distance time graph. Now remember, if the object is moving with the if the object is moving with constant speed, right? Constant speed, then we will have the straight line. Okay, right? So from a distance time graph, we should know that the speed is actually the gradient, right? Okay, so
Yeah.
gradient of distance time graph is the speed, right? So at any point on this straight line, if you calculate the gradient, so it will be constant. So gradient of distance time graph will be constant if the object is moving with a constant speed.
Okay.
Now, if the body is uh, not moving, or let's say at rest or stationary, so the line, there will be the horizontal line that shows there's no change in the distance, right? So either you draw at a certain height on the y-axis, right? Or you draw at this point. So both indicates the the graph, distance time graph, but the speed if the body is not moving or is at rest, right? The third concept is if the body um is speeding up, right? Speeding up, right? Speeding up, and that means body is accelerating. Yeah. So speeding up or accelerating means the rate of change is increasing, right? In a distance time. So the graph is going to be like this. There will be the curve, right? This is how the distance time graph would be for the body that is speeding up, right?
Yeah.
Okay. The fourth one, slowing down, slowing down. Okay. So if I draw the graph of the body, which is slowing down, okay, so the time is there, distance is there. So I'm going to have this. Okay. I hope this is clear, right?
Yeah.
These are the four distance time graph for the speed, right? Changing speed. This is for non-uniform speed, non-uniform. These two graph, 3 and 4, graph number 3 and 4, non-uniform speed. Okay, that means the object is not moving with the same speed. I hope that till here it is clear. Now we're gonna work um uh, for the speed time graph. Okay, speed time graph. Let's talk about uh, okay. Let's talk about acceleration. So what is acceleration? Any idea what acceleration is?
When an object moves forward in motion.
When object is, sorry.
When it's in motion, like it moves forward.
Okay, so if the object is moving with the same speed and it is not changing its speed, so do you think that it is accelerating?
Yeah.
Do you think that it is accelerating if it is
Oh,
moving?
the object.
If the body is not changing its speed, tell me if the body is not changing its speed and it is moving with a constant speed like 20 meter per second, right? So, do you think that the body is accelerating?
Mm,
No. So remember that
no.
acceleration is acceleration is the rate of change of velocity. So therefore, we say that change of velocity per unit time is acceleration. Okay, or change in velocity per unit time gonna be acceleration. Clear?
Yeah.
Right? Now we have the graph for the acceleration. But tell me which graph is going to be for acceleration. Distance time or speed time?
Speed time.
Speed time, right? Okay. So if the object moving with moving with uh, constant speed, right? So how would be the speed time graph?
It would be like a horizontal line.
It's going to be horizontal line. Okay, that's great. Right. And if the body is moving with a constant acceleration,
It'll be like a diagonal line upwards.
okay. So what does this mean, constant acceleration?
It's moving with the same speed.
Is it moving with the same speed? Are you sure? If the body is moving with the same speed, so is it accelerating?
No.
Then it's a constant acceleration, right? And we have to draw
Yeah.
a speed time graph for the constant acceleration. Yes. Think about it. Okay, so speed time, and we are going to link with the acceleration. When we link the distance time with the speed, so we were talking about the gradient. Yes, over here,
Yeah.
the the change, the um, rate of change is increasing, right? That means gradient is increasing at every point. Okay, at every point the gradient is increasing, and over here the gradient is decreasing, right? Yeah.
Yeah.
Okay, so we were talking about gradient in the distance time graph to represent the speed. Clear? Now over here we have this speed or velocity time. Okay, and we have to represent the acceleration. So are we not going to talk about the gradient? We will talk about the gradient. Okay, so
Okay.
gradient is line should be the straight diagonal line, which is going to have the constant gradient. Okay, so what are we going to say? Gradient is constant. And here, what does gradient of speed time represent? Speed time of the sorry, gradient of the speed time graph represents acceleration. Clear?
Yeah.
The gradient of speed time represents acceleration, and we have to specify it magnitude of acceleration. Magnitude. Magnitude of acceleration. Now, if I talk about the area, if I talk about the area of this region, so what will I get? Area of speed time graph. What does it represent?
Mm.
Area of speed time graph represents
Oh, distance.
distance, right? And if I want to find out the area, or if I want to find out the distance at this particular time, right? How much the distance is traveled by the body. So I have to find out the area. Area is equals to distance traveled. So I hope this is clear to you as well, right?
Yeah.
Okay. Now, if the body, the acceleration is constant, so can we say the speed is increasing? Yeah,
Yeah.
constant acceleration. But can you see here the speed is increasing? At every point, the speed increases. Clear? So
Yeah.
in constant acceleration, the speed increases, right? Okay.
Yeah.
And the gradient is going to be positive. Gradient is going to be positive. Now, if I say that the acceleration increases, there could be the another possibility that the acceleration increases, right? Acceleration increases and the body is speeding up, right? The body is speeding up, right? At a different rate, at a different rate. So since we are saying that body is in having non-uniform motion, we can say, and acceleration is increasing. So how would the velocity time graph be? First of all, is it going to be a straight line or a curve?
Mm,
Hello,
a straight line.
a straight line. So what is the difference between a constant acceleration and a variable acceleration?
But in a straight line, like towards up, towards up, so like a diagonal line.
Yeah, it's going to be diagonal, okay? Oh, sorry, it's not going to be diagonal. Okay, so is it not diagonal here in this
Yeah.
example number two? There is a diagonal line, and we are saying in that the body has the constant acceleration, right? So when I say acceleration is increasing, so even then I'm going to have the straight diagonal line, or is it going to be a curve?
Oh, curved.
It's going to be curve, right? Because the gradient is not constant, remember. Am I saying gradient is constant?
No.
No. So gradient is going to increase. That means rate of change increases. Acceleration increases means rate of change increases, okay, in the speed time graph. So it's going to be increasing curve, right? It should not be, it should not become parallel to the y-axis, right? Number one.
Yeah.
And what do you think if I draw the tangent line here? Is it is it becoming steeper and steeper?
Yeah.
So that means gradient is increasing or not?
Yeah.
So that means gradient increases, number one, and gradient means the rate of change increases. Rate of change increases. Number one. Number two, acceleration increasing. That's how we have developed this graph. Acceleration increases. It's no more a constant. And this third thing, is the speed increasing or decreasing?
Increasing.
Yes, speed increases. Clear? Now
Yeah.
the fourth case, the acceleration is decreasing. Acceleration decreases.
So then it's curved downwards.
Okay, so that means body is slowing down. Yes, body is slowing down at a different rate. So how the speed time graph would be? Clear? Is
Yeah.
is going to be um decreasing curve. Okay, when the body is having the acceleration decreased. Okay, so acceleration, when acceleration decreases, the speed time graph going to be a curve, but decreasing curve. Okay. So what we can say, what we can claim here, what we can claim that gradient increases or decreases? Decreases. At every point, if I
Decreases.
draw a tangent line here at different points, so it becomes more less steeper, right? Okay. So therefore, acceleration decreases. And- Okay. Hello. Are you getting this
Yeah,
concept? And tell me what would be the speed? Is it decreasing or increasing?
it's decreasing.
Decreasing, are you sure? If the body at this point is moving with this speed, so at this time, what is the speed? Is it more than the previous one or the lesser one?
It's more.
It's more. So what do you think? Is it going is
Over
it
there,
going to
it's
have
increasing.
the greater speed or lesser speed? Sorry, speed increases. Should I say speed increases or decreases? See, every time the magnitude of the speed, see, it is increasing, but at every second, 1 second, the rate of change is not constant. Number one, the rate of change is not constant. Number two, the rate is decreasing, right? So for every 1 second, the change of the speed is decreasing. The change of the speed is decreasing, but speed is increasing. If I put numbers here, 1, 2, 3, 4, tell me, and this is 1, 2, 3, and 4 second. Now tell me when the object is moving in first second, the object has one speed. Okay, say one meter per second. Okay, now in the second 2 seconds, now it's going to have the three 3 meter per second. In the third second, it's going to have the 4 meter per second. Then the fourth one, it's going to have the 4.5. Now it could have near to 5, but the change is decreasing, right? The change is decreasing. At every point, the body is changing its speed, but the difference between the previous and the next is going to be smaller and smaller and smaller. Therefore, what we can say, the rate of change decreasing, but the magnitude of the speed increases.
Okay.
See, if the body is here, let me put more. if if the body is here, right, at 1 second, right? Now tell me in the next second, if you say that the speed is decreasing, so will the body have to be there or here? If you are saying the speed is decreasing, so don't you think that the body has to reach at this point? Yeah.
Yeah.
Okay. So, but the graph is showing that the body is having more speed, right, in each second. But the difference in the next speed is becoming lesser and lesser. Okay, clear?
Yeah.
All right. So altogether, we have discussed four graphs in of a speed time and four graph of distance time. And in the distance time graph, when we say the speed is increasing, right? So this is how the graph will be drawn. So speed increases. Why? Because the rate of change is increasing. And over here, speed is decreasing. So this is called decelerating or deceleration. And this is acceleration. Now let's talk about the um, I'm going to talk about uh, speed time graph of the object reaching to the terminal velocity. Or the body reaches terminal velocity. Okay, so the graph is when the body, starts falling or when it begins to fall, okay, let's say at point A, the skydiver, let's talk about the skydiver, accelerates as they begin to fall. So remember when the skydiver starts to fall, so it's going to accelerate, right? And the speed time graph, I'm going to complete the graph here, okay, one by one. So it's going to have okay, so speed, the skydiver is going to accelerate, okay? So initially it's going to be like that, okay? And let me call it A. In the second step, as the skydiver speeds up the air, speeds up the air resistance, okay? The air resistance increases, right? Okay, air resistance increases. So what do you think, is the speed going to decrease or is it going to become same? The speed is going to become same, right? It is going to become, sorry, it is going to decrease, okay? So it's going to decrease, right? So here this is going to be B. Now let's talk about the next step. At the terminal velocity, At the terminal velocity, the air resistance and weight are equal. So what will happen when the two forces become equal? According to the Newton's first law of motion, the body will continue to move with a constant speed, right? So the skydiver moves with constant speed. So the graph is going to become horizontal. So here the terminal velocity is reached, right, by the skydiver. In the fourth step, when the parachute opens, what happens? When parachute gets opened, so which will increase the air resistance, right?
Yeah.
Okay. So it will slow down the skydiver, right? So what will happen? This time, the magnitude of the speed is going to decrease, right? And the graph would be 40 here. Okay. And it will continue to move and keep going, and decreasing its speed. In the part E, the you know the skydiver will continue to slow down, right? The skydiver continues to slow down, right? Until when? Until air resistance, until air resistance and weight both become balanced again, right? Weight both become balanced again, right? And so a new terminal velocity is reached. Terminal velocity is achieved, right? So it will continue to decrease, and then it moves with the same speed, okay? With the same speed, and then comes back to the ground immediately. So where should be E when it becomes a horizontal line again? So this is how the terminal velocity time graph is plotted. Okay, right?
Yeah.
And we have one question. If I have, oh, okay, I have only 1 minute, so let me let me try if I can complete. The question says that the question says that. The question says that in the first part of the fall, the speed increases and acceleration decreases. We have to draw the speed time. So there will be the decreasing curve. Okay. There will be the decreasing curve, right? And in the second part, the speed is constant. Then there will be the horizontal line. So the first part is A, second part is B. This is the speed time graph. This is the past paper question.